All right, well, we got the technology figured out, so thanks for coming. I'm Dr. Michael Hartsock. I'm a professor of philosophy and the director of our honors program here. And this is really just to kind of give you a sense of maybe really even sort of a glimpse into what we do in classroom. I'm a philosopher of science, and so we're going to talk a little bit today about the evolution of morality. And the basic question is this. If we are products of evolution, that is, we are shaped by natural selection, to what extent are our behaviors, including our moral behaviors, shaped by natural selection? Early on in evolution, in the history of evolutionary theory, it was very difficult to explain how we would behave morally if, as it seems, nature is one of pure competition. So what advantage would it be to an individual to help his fellows if it was at some cost to himself? Recent work in evolutionary theory and branches of applied mathematics like game theory have given us a handle on how to at least approach some of the questions that we're addressing. Okay. And, but we'll look at today some of those approaches. We'll look at it in animal models and then also think about what other questions there are that have yet to be addressed. May have to have my assistant click to the next slide. Okay. We start with Richard Lewontin's formulation, just because it's a nice way to understand what is required for natural selection to act on an organism or a trait. And so Lewontin's formulation is that natural selection can operate on an entity which exhibits heritable variations in fitness. And so this gives us a nice way to think about how or in what way natural selection might act on morality, because if it's going to, then our moral behaviors have to be in some way heritable, which we can largely account for. They have to be variable. There's no doubt high variability in human moral behavior, moral and immoral. But we're going to focus today on the fitness component there. Next slide, please. All right. So, not knowing exactly what the audience is going to be like here today, I decided to pitch it pretty broad. So, just looking at an understanding of what fitness is, here I'm using terms like fitness, natural selection, and if you don't have much background in evolutionary theory, the one thing that might come to mind is an expression, survival of the fittest, which I might point out Darwin himself never said, and is a rough approximation of something that Herbert Spencer, a sociologist, said. And that itself isn't very helpful. It's really just a truism. If survival of the fittest simply means that the fittest are the ones that survive, it's pretty meaningless because fitness is measured in terms of survival. And so it would only mean survival of the survived, which doesn't do us a lot of good. So we want to dial in, drill down a little bit here and understand roughly at least what we're talking about. Fitness is a probability. So it's the probability that a given organism will be a parent in the next generation. And so what we're looking at in natural selection is the change in gene frequency. So it's really an average of a genotype or a phenotype, so some trait or some gene, and its average propensity in the next generation. And since we think about it in terms of natural selection, the traits then that persist are thought to be adaptive. That is, they give the organism some advantage in their environment, where natural selection acts as a kind of filter, promoting traits that give an organism a survival or reproductive advantage. Next slide, please. There we go. All right. Yeah, okay, so there we go. And this allows us to kind of frame the central problem. If morality is the product of evolution, then morality must give the organism a survival advantage. And that's where it starts to seem a little bit odd. We get back to the modern philosopher, Thomas Hobbes, early modern philosopher. Moral philosophy is nothing else but the science of what is good and evil. in the conversation and society of mankind. Good and evil are names that signify our appetites, aversions, which in different tempers, customs, and doctrines of men are different. So we see that even in this early era, well before Darwin's work, we have philosophers thinking that there's something about our natural inclinations and aversions that are central to our understanding of human morality. Give it a shot. Hey, look at that. Okay. Now, to start with, I'm going to invite you to think about a possible but not real, so it's a thought experiment, an example. So imagine an island, isolated island, and there are two people living on it. One who is an angel. They are perfectly cooperative, they are perfectly altruistic, and the other is a devil. They are the perfect cheater. Now, it doesn't take, I don't think, a whole lot of philosophy or science here to understand what's probably going to happen. Who's going to win? What do you think? The angel's going to win? It's very optimistic. We hope, right? No, the fear is that the angel's going to be shark bait in a short period of time. Okay, you've got somebody who's perfectly cooperative and perfectly altruistic competing against somebody who will do anything to succeed. And it doesn't seem like the angel's going to fare too well. We see this in Lord Tennyson's In Memoriam, where we get the phrase that nature is red in tooth and claw. So the problem we're faced with is this. If morality is the product of natural selection, that is, if morality is to confer upon us some kind of fitness advantage, then we have to imagine a situation in which morality, being the novel trait in the environment, could have succeeded against the background of a nature which is red in tooth and claw. But it's not quite that simple, because that would suggest to you that there's no way that morality would evolve. So morality, since it clearly exists, people do behave altruistically, couldn't be accounted for through natural selection. But now imagine two separate islands. One island which is populated by all and only angels. That is, these are people who are fully cooperative, they tell the truth, they get along. So you just imagine your paragon of human virtue, and this island is populated by all and only those people. Now you imagine another island, Devil Island, and this island is populated by all and only vicious people. So you imagine the depths of human depravity and avarice, and that is what these people are like. So on the one island where we had one angel and one devil, we worried about the fate of the angel. But now, which island do you think would succeed relative to one another? Angel Island, right? I mean, how hard is it going to be to engage in agriculture if everybody's lying, cheating, and stealing? How are you going to put up stores for the winter if there's no guarantee that they're going to be there for you when you need them? Devil Island would pretty quickly collapse into chaos and violence and not survive. But Angel Island would do well. But again, when I looked for pictures of angels and devils, this was the first that came up. It seemed appropriate. Now imagine that one devil swam over to Angel Island and invaded. Now what happens? The first two cases were fairly clear. Okay? On Angel Island, everybody's going to do well. Devil Island, they're going to fail. Put an angel and a devil together, the devil's going to win. So it's better to live among angels than among devils. But what happens when one devil invades? And this is instructive, but much less clear as to what's going to happen. Okay. Would my assistant please click Activate Adobe Flash? In my defense, this is Google's fault. No. There you go. In the middle, Activate Adobe Flash. Allow to render. There we go. Will you please play the video?
A pot of hazelnuts and the flint that's needed to open the lid. You need both to get a nut, but they're separated by a see-through barrier. Vulcan has the rock, but can't reach the nuts. Virgil has the nuts, but knows he can't eat them without a rock. Vulcan quickly offers the tool. He must hope Virgil is smart enough to open the lid and fair enough to cut him in on the spoils. Virgil is stumbling. He doesn't have his friend's skill. And Vulcan is getting impatient. The flint is finally through the lid, but can Virgil be trusted to share the nuts? With Vulcan out of reach, it must be tempting to take the lot. Three nuts, a fair share. Vulcan and Virgil have used teamwork to beat the system. But can Capuchins really have a sense of fair play?
So it's actually a surprising result. Here you have a situation where, and I think this is pretty clear from the short film, you've got a situation where one monkey has the nuts but can't get to them. The other monkey has the tool to get to them. Gives the tool to the other monkey. Now, that's not that, there's no cost really associated with giving him the tool. You don't need it for anything else, okay? But at the same time, you've got Virgil, the monkey who ends up sharing the nuts, who now has both the tool and all the nuts. And there's no way that Vulcan can take them from him by force. So there's no clear incentive for Virgil to share. And yet, and these kinds of experiments have been repeated over and over again with chimpanzees, capuchin monkeys, and a variety of other primates, that nevertheless, they reliably share and share evenly. This would be a surprising result, right? I mean, and we step back to the animal models because oftentimes when we're thinking about human morality, we get trapped up in thinking about the individual human moral codes and the variations among them. But if we're interested in understanding whether or not morality can be produced by natural selection, we look to animals which we have no doubt are nothing but the products of natural selection. And we see, at least, we see hints of a sense of morality, fairness, for example, fair play, cooperation involved, and altruism, that is, an act which is sacrificial of yourself for the benefit of another, which we see with Virgil. He could have kept all 6 nuts, and now he's the victor, he's the champion. Sucker, Vulcan gave him the rock in hopes that he would play nicely and share, and he wouldn't have to, but nevertheless, he does. So we see moral-like, we'll put it that way, behaviors in primates, and these kinds of experiments have shown that these kinds of interactions and senses of fairness occur with other social animals as well, including dogs. But we also see a sense of justice. That is, not only is one animal willing to sacrifice of himself to benefit another animal, but we also see a sense of justice. That is, a sense that the animals demand something because they feel that they deserve it. Yeah, go ahead and play.
So a final experiment that I want to mention to you is our fairness study. And so this became a very famous study, and there's now many more, because after we did this about 10 years ago, it became very well known. And we did that originally with capuchin monkeys, and I'm going to show you the first experiment that we did. It has now been done with dogs, and with birds, and with chimpanzees. But with Sarah Brosnan, we started out with capuchin monkeys. So what we did is we put two capuchin monkeys side by side. Again, these animals, they live in a group. They know each other. We take them out of the group, put them in a test chamber. And there's a very simple task that they need to do. And if you give both of them cucumber for the task, the two monkeys side by side, they're perfectly willing to do this 25 times in a row. So cucumber, even though it's really only water in my opinion, but cucumber is perfectly fine for them. Now if you give the partner grapes, the food preferences of my capuchin monkeys correspond exactly with the prices in the supermarket. And so if you give them grapes, it's a far better food, then you create inequity between them. So that's the experiment we did. Recently we videotaped it with new monkeys who had never done the task, thinking that maybe they would have a stronger reaction, and that turned out to be right. The one on the left is the monkey who gets cucumber. The one on the right is the one who gets grapes. The one who gets cucumber, note that the first piece of cucumber is perfectly fine. The first piece she eats. Then she sees the other one getting grape, and you will see what happens. So she gives a rock to us, that's the task. And we give her a piece of cucumber and she eats it. The other one needs to give a rock to us. And that's what she does. And she gets a grape. And she eats it. The other one sees that. She gives a rock to us now, gets again cucumber. She tests the rock now against the wall. She needs to give it to us. And she gets cucumber again. So this is basically the Wall Street protest that you see here.
Equal pay for equal work, right? So what these two experiments just give you a sample of is what seems like it would be at odds with natural selection, with a nature who's red in tooth and claw. That is, on the one hand, you've got a monkey who would be better off individually if he were to just keep all the nuts for himself, and yet he doesn't. In the second place, you've got a monkey who will give up cucumber, which is better than nothing, because he demands to be treated equally, which is very strange. Surely, no matter how you feel about cucumber, cucumber is better than no food at all. And yet the animal is willing to sacrifice, really what seems like to make a point, right? To demand that that he be treated equally. And again, we see these behaviors in capuchin monkeys, we see them in other primates and other social animals. Probably going to have to play it again. Now, there is a framework for thinking about this, and I mentioned earlier some of the work that's being done in game theory. One of the classic examples is called the prisoner's dilemma. The prisoner's dilemma is set up this way. You've got, you imagine two prisoners who are being interrogated individually. They're being separated from one another. And interrogators make to each of them the following offer. They say, if you, we don't have any evidence to keep you or your comrade in jail, but we can hold you for 1 year without charges. And if you are quiet and your comrade is quiet, then we're going to hold each of you for 1 year in prison, which is not a great deal. But if you give evidence on your comrade, then we're going to let you out today, and we're going to put your comrade in jail for 10 years. But here's the problem. We're going to make the offer to them too. And if you both rat each other out, then we put you in prison for 5 years each. So you got a framework for thinking about the kind of competitive environment, right? On the one hand, if you're cooperative and your comrade is cooperative, great, right? That's how we all succeed. That's the kind of cooperative activity that makes possible all the kinds of things that we enjoy in society. On the other hand, if you are cooperative and you're playing against somebody who is, in game theory we call them defectors, somebody who's going to cheat, then you're in a lot of trouble, okay? But the problem is, now you got to decide what you're going to do. And while we hope that everyone cooperates, the point is that no matter what the other person does, you are rationally better off defecting. We see that in the following matrix. The way these are laid out is that player B's, and this is put in terms of rewards. So there's arbitrary numbers that are your reward, whether it's money or cucumber or whatever, or nuts. These are your reward points. So if you're a cooperator, player B, and player A is a cooperator, then your reward is 3, right? You each get 3 reward points. However, if you cooperate as player B and player A defects, then you're in trouble. You get nothing and they get 5. Now, if you'll pay attention to the way these are structured, and these match, the numbers could be anything, the rewards could be anything. But basically, no matter what the other person does, you're better off defecting. Because if you defect and they cooperate, then you hit the jackpot. And if you defect and they defect, then thank God you didn't cooperate, because you'd be much worse otherwise. So what we're looking at is trying to understand how, given these kinds of dynamics that we see in nature all the time, right? The monkey could have kept all of the nuts for himself, he gets the big payout. The other guy's left with nothing because he cooperated, right? Whereas he could have held out and not given the other guy anything, and at least he's got a tool. Maybe he could use it later. Similarly for the cucumber, sure, you'd rather have the grape, but having nothing is fewer points than having cucumber, which may be only a few. We solve these problems through understanding them through iterated prisoner's dilemmas. That is, we have to imagine environments where animals are playing against each other more than once, and they can have complex strategies. It's been demonstrated that the most effective strategy for playing the prisoner's dilemma, and you can model these in computer simulations and things like that, the most effective thing to do is to use a strategy which is called tit for tat. Basically, I'll scratch your back if you scratch mine. So the first time you play against, think about it in terms of opponents, right? We're abstracting away from animals. But the first time you play, you be cooperative. But you've got to have a memory or a reputation for the other person. If they defect the first time you play, then when you play with them again, then you defect. Cooperator. And next time you play against them, you cooperate. So that it limits the impact that the cheater can have on the system. And so that in certain social environments, we would expect then cooperative behavior to evolve. And so we've got an account for understanding why our capuchin monkeys act the way they do. They're not playing one-off games against each other, right? They're engaged in sustained cooperative behavior. But only under certain ideal conditions would we expect this to arise. We go back to our Devil Island. Our Angel Island where the devil invades. There's difficult questions about how much impact that devil could have on the environment. Recent work in evolutionary theory give us mathematical models for thinking about just how stable cooperation is under the incursion of defectors or uncooperative individuals in an environment. And so there's some mathematical, which we can hum and not worry about today, but there's some mathematical framework for understanding how this works. The unsettling implication of this, at least as it is argued by some, is that the kind of morality we get out of an evolutionary framework is not really what we thought morality was. Morality ends up being a kind of sustained illusion where altruism is really just reciprocal altruism. Our angels that succeed are not pure angels, they are reciprocal altruists. They are nice to you insofar as they can get something out of it. Which strikes us as not exactly the kind of morality we hoped we find when we turn to the rocket order. But there may be more to understanding human morality than merely the rather dim lens of understanding it through moral behavior of the chimps, bonobos, and other social animals. There's real questions, and this is where the philosophy tends to step in, right? We're interested in the logic and the mathematics of the game theoretical applications, but at the same time, we shouldn't be just assuming that because we've managed to explain the behavior of bonobos and chimps through a purely evolutionary framework, that that's all there is to it. There's hard questions left about whether or not explaining the kinds of behaviors engaged in by these animals also by extension explains the behaviors we see in humans. For example, if we're to understand the evolutionary impact of, so you've got these animals and they're cooperating, they're playing nice with one another. We wonder what would happen if an animal from another troop comes in and also offers a rock. What we see in the wild and in laboratory environments is really very little cooperation between the outsider and the insider. That is, we would not expect humans, if our evolution is a product in the same manner in which the bonobos is, we would not expect people to give of their time, resources to strangers in distant lands who are starving. And yet, time and time again, we do. If morality was really just an illusion to get us to be cooperators because in the end it's good for us, then we wouldn't expect soldiers to lay down their lives to protect people they've never met. And yet we do. There does seem to be something that goes beyond the mere cooperative behaviors. That is, behaviors that animals engage in that we can look at, compare to our own, and describe as moral. That is, we have moral concepts, and we engage in moral judgment, which is surely something that the animals don't engage in. That is, we are capable of thinking about a situation and using conscious deliberation and deciding what to do. So that we end up with perhaps three possible options for thinking about the relationship between morality and evolution. On the one hand, we can accept the explanation that moral behaviors are all there are to human morality, and those are the product of evolution because they enable us to be better cooperators, which benefits us. And morality then is just a complex natural illusion. We might, though, on the other hand, accept that many of our behaviors, which we properly describe as moral, are the products of natural selection. That that's not all there is to understanding morality. That there's something about human understanding, intelligence, and consciousness that is additive to that evolutionary story, that does more than simply encourage certain behaviors in us. And it may be because our complex intelligences are the products of natural selection that then enable us to comprehend the moral law. That there's something which is not inaccessible to us, something that's not purely non-natural, but nevertheless tells us something more to morality than simply these evolved behaviors. And of course, finally, there's the option to say no, morality is simply non-natural, can only be understood through a religious or a spiritual lens. And there's nothing that evolution can tell us. While that may be an attractive view, it certainly does leave open then why the bonobos are so nice to each other. And why we see so much of ourselves in the bonobos and the chimps and our nearest natural ancestors. But nevertheless, there are still questions to ask. That just gives you a sense of the kinds of things that philosophers of science like to think about. So I guess we're out of time, and I apologize. Any quick questions, thoughts? I actually thought that was going to be a 15-minute talk. It took longer. All right. Well, thanks everybody for coming. I know we've got somebody else coming up next, and enjoy it. So good luck to you and your students today.